All right, I hope that you guys worked on these things, because again, this is a very nice problem, and I can virtually guarantee you that it will appear on your next exam and the final as well. We have up here a selection of compounds, and we have something that we're trying to make. The instructions are you have to make this two ways using things that are up top. Now these are all carbonyls, so what we're going to have to do is identify the proper carbonyl compounds and then just make up the Grignard reagent to go with them. When you do one of these problems, the first question you do is, the first question you ask, is to look at the thing you're trying to make and say, what is it? Well, it's an alcohol. But because we're doing Grignard, you need to be a little more specific. This is a secondary alcohol. Because it's a secondary alcohol, what you say to yourself is, if we take an aldehyde and add a Grignard, we will make a secondary alcohol. So that's step one. Step two, you want to take and split on both sides of the carbon bearing the hydroxyl group. Remember, the hydroxyl group used to be a carbonyl, so we're going to split on both sides and see what carbonyls we would need. Start on this side. If this is the bond we made from our Grignard to our carbonyl compound, then the aldehyde had carbon-oxygen double bond, benzene ring, and a hydrogen. So that's benzaldehyde. Simply look up top. Benzaldehyde is the carbonyl compound that you need. Next, you say, okay, everything on this side came from the Grignard. So you want to draw the structure of your Grignard. That means our Grignard reagent here had 1, 2, 3 carbons. This is attached to a hydrogen, and it used to be magnesium bromide. And that would do it.
Are you recording this, Dr. Young?
Yes, I am. Any questions? All right, let's go ahead and do the other half. We're going to split here. So do the same exercise. Look up top, find the carbonyl compound that would react with a Grignard to make this stuff. This used to be a carbonyl. Has an isopropyl group, and of course a hydrogen because it was an aldehyde. Up top, this works. Remember, this is a methyl group. That doesn't work. We have hydrogen, a secondary alcohol. This will give the secondary alcohol because it is an aldehyde. Our Grignard is simply our benzene ring attached to magnesium bromide. Now isn't that fun and simple? Let's look at the next one. I will pause for a moment while you ask yourself the magic question. Split on both sides, and then identify your 2 carbonyls and your 2 Grignards. Once again, we're dealing with a secondary alcohol. So we're looking for aldehydes. All right, let's split on one side. This side used to be the aldehyde. Once again, this was a carbon-oxygen double bond. Has a hydrogen and a benzene ring. And once again, it is benzaldehyde. Our Grignard. Well, the Grignard has 4 carbons. Magnesium bromide was attached to this carbon. Isopropyl group out here. That would do it. Split on the other side.
I have a question.
Yeah.
For the Grignard, for the one that you just did,
Huh?
does it matter where the methyl group is?
What, these guys?
For the Grignard. Yeah.
Yeah, this carbon skeleton here. These 4 carbons must match these 4 carbons exactly.
Does matter.
So it couldn't be a straight chain.
Nope. Nope, no rearrangement. All right, split on this side. This used to be a carbonyl. It was an aldehyde. It has a CH2 and then an isopropyl attached. And we look up top, and that guy works fine. Our Grignard is simply the other half. Once again, this is just a benzene ring attached to magnesium bromide. Any questions? Well, let's do our next one. What kind of compound is it? Well, it is a secondary alcohol again. So again, we're looking for aldehydes. Let's split on one side. So the carbonyl part, this was a carbonyl carbon. There's a hydrogen, it's an aldehyde. And there's a straight 2-carbon chain. Up top, that one works. The Grignard half. Grignard had 3 carbons. with magnesium bromide attached to the center carbon. I split on the other side. Still looking for an aldehyde. The aldehyde is attached to an isopropyl group, isn't it? Therefore, the one we want is this guy up top. Now our Grignard is the other half. It is simply 2 carbons, so an ethyl group. And this would be ethyl magnesium bromide. Any questions? Well, let's do one more aldehyde here. If we split on this side, the aldehyde, this was a carbonyl, has a hydrogen, CH2 isopropyl. That went up there. And what's our Grignard? Well, our Grignard only contains 1 carbon, doesn't it? So this is just methyl magnesium bromide. On the other side, this used to be our carbonyl carbon. It was attached to a hydrogen and to a methyl group. Acetaldehyde is what we want. Our Grignard is simply the other half, which is a CH2 attached to the magnesium bromide, and then an isopropyl group. Any questions? All right. What is this guy? This guy's a tertiary alcohol, isn't it? Now we can make tertiary alcohols a couple ways. We can make them easily from ketones, or we can make them by addition to esters. Let's start off with just clipping one of the side groups here. And we're going to be looking for a ketone. The side group we're going to clip is going to be that. Now that means our ketone, this used to be our carbonyl here, Our ketone simply had two ethyl groups attached. So up top, that one works. And what did we add for our Grignard? Our Grignard simply had two carbons, so that's an ethyl, and that would be ethyl magnesium bromide. Now, there are no more ketones up here that would give us this tertiary alcohol. Diethyl ketone is the only one. So, let's look at this and say we could also make this tertiary alcohol from an ester. I remember, Grignards add twice to esters. So, two of these little groups hanging off here came from the Grignard. So let's clip those off. And that means our ester had a carbonyl. Attached to the carbonyl is an ethyl group, this two-carbon chunk, and then something else. But it doesn't matter what else because we lost it, didn't we? Washed it into the river. So we're looking for an ester with an ethyl group and something else. I think that that one would work. Again, we just lose the methoxide, and we're only interested in this half. Our Grignard came from these little two carbon chains. We need two of them, so two ethyl magnesium bromides.
What went into the river again, Dr. Young? What went into the river again?
Methoxide. Remember, we add here. And this stuff leaves, forms a ketone, and then we add again. All right, well, we're back to secondary alcohols. So we know we can make a secondary alcohol from an aldehyde. Go ahead and pick an aldehyde, and let's do this. Live on one side. Our aldehyde simply had the carbonyl carbon attached to a hydrogen and an ethyl. Our Grignard reagent was simply the two-carbon chunk, and that's ethyl magnesium bromide. Now we need to do this two ways, don't we? And there isn't another aldehyde up here that works. So what do? Well, in a special case, remember, we can also make symmetrical secondary alcohols from a formate ester. Formate ester, derivative of formic acid, has a hydrogen on one side and then the OH on the other. Formic acid is properly called methanoic acid. Formic acid is the toxin that's in an ant sting. So it's just a little simple acidic compound. All right, so we're looking for an ester based on formic acid. That means instead of a hydrogen here, we need something else attached. And the one that works is going to be this guy here. Because it's an ester, we added 2 moles of Grignard to it. Our Grignard was simply the 2-carbon chunk. And again, that's 2 moles of ethyl magnesium bromide.
I'm a little confused when we're talking about the difference between an acid and an ester. Because
Carboxylic acid, we have an OH attached directly to the carbonyls. This is an acidic hydrogen. Okay. A carboxylate ester, we take and replace the hydrogen with something, some carbon compound. So it can be an alkyl group, vinyl group, aryl group, whatever, anything.
but it wouldn't be OH.
Not OH, right. OH is the acid. O methyl, O ethyl, O phenyl, whatever. That's all a carboxylate ester.
Because I guess why I was confused because you said that we're adding an ester, but you showed us the formic acid, and that just
Right, oh, okay. Well, because I said formate ester. If you don't know what formic acid is, then you don't know what a formate is. do you? Yeah.
So if you use that bottom left one, isn't that an ester?
This guy.
Could you double add that to
If
make?
we did this though, we would double add here, wouldn't we? And we get the tertiary alcohol. You can't just add only once.
So you're only double adding when you're dealing with tertiary
Right.
alcohols.
Double adding will give you a tertiary alcohol, except in the case, the one special case where we have a hydrogen attached. This is an ethyl group, that doesn't work. This hydrogen is the one that shows up here. Now this isn't so difficult, is it? We'll try to do some more practice problems like this as we work through the rest of these chapters, okay? All right, let's go ahead then and set up to do the lab. In the lab, you're going to use acetic anhydride. Salicylic acid. Salicylic acid is not particularly toxic, but sulfuric acid, of course, is. And you're also going to use acetic anhydride. We haven't talked much about activated acyl groups. Acetic anhydride will cause burns. Please be very careful with it. Don't splatter it on yourself. Make sure you wear gloves and your goggles. What you do is simply mix these things together, add a little bit of sulfuric acid to it, kind of just swirl it around. It'll get hot. As it's getting hot, you just sit there and swirl it, let it cool down. Once it starts to cool down, you should get solid forming in the flask. That will be acetyl salicylic acid or aspirin. If you have trouble getting the stuff to appear, so it, not crystallizing out, there's a little jar in the hood with some real acetyl salicylic acid in it. Just take 1 crystal, don't cheat, add a bunch, just add 1 crystal and it should hit and then induce the crystallization. It's called a seed crystal. And then you get your stuff. Once you want to set up a simple vacuum filtration, once you get your solid, kind of wash it out with a bit of water, filter it off, and I think you're going to recrystallize from a little bit of ethyl acetate. Make sure you add the ethyl acetate nice and slowly. Warm it up a little bit, so get a hot plate. Warm it up a little bit. There's some ice there. Cool it down. You should get nice crystals.
take a melting point.
Take a melting point. That's it. We could do an IR. Unfortunately, we're not really set up to do IR of solids quite yet. And this is a solid, so. Plus, acetyl salicylic acid gives a really ugly infrared spectrum. All right, let's do it.
I assume it's in the book somewhere.
362.
What's the page for today?
Something for us to do, I just didn't want to say, but
No.
go check it.
Yeah, just check.
Do I like have the
Okay.
pages from last?
Cause when I got the test back, like I know what I messed up on, and I'm glad that I got a big one from the rest one, but like, some of those other ones, I don't know,
I don't trust you.
the Diana files and stuff have really been, I don't know why they're so confusing. And I know that that's what really brought me down, cause I was like, okay, I had gotten it right, but I was just like, I was just like, oh my god,
It's cool, no one do it.
how am I putting these together?
No one do it.
I wanted to see what I can just listen to. Okay, like for the review or something, okay.
Well, I was gonna ask if you had the right email on file for me, because I never got any emails like the last couple of weeks.
Oh, no?
I never get an email, so I never got it.
It went out. I got a copy.
I'm saying, like, do you want to see if you have the right email on file?
Okay, I suppose I can do that.
It's weird because I emailed you like that first week, and then never saw any emails after that.
No, it's all
You get a
done
chance,
through.
I'm missing